All right, in this video, we're going to talk about the idea of horizontal asymptotes and then limits as the x's are going to infinity or negative infinity. So we're going to start out by looking at these two limit statements. The first one says the limit of f of x as x approaches 3 is positive infinity. The other one says the limit of f of x as x approaches infinity is 3. So they're not the same thing. There's a subtle difference. So the first one, we just looked at them in the last notes. This was the definition like a vertical asymptote. So this means there's a vertical asymptote at x equals 3. I guess we could have wrote this out here. What do each of the limit statements tell us about the graph? So the first one, in that form, as x is approaching 3, we have a vertical asymptote at 3 because the limit's infinity. It's going up forever. Sometimes you see that it says does not exist, but if the limit is infinity, we're going to say it's a vertical asymptote. All right, the next one, it says the limit as x approaches infinity is 3. So this means there's a horizontal asymptote at 3. It could be something that looks like this. So the limit as x approaches infinity is 3, or it could come up from below and gets really, really close to 3. But the y numbers are getting really, really close to 3. So look at that difference. If it's the limit as x is approaching a number gives you infinity, then there's a vertical asymptote. If it's the limit as x approaches infinity is a number, that means there's a horizontal asymptote. All right, so to get an idea on what's going on and to be able to look at these things really fast, I want to be able to look at this equation and I want to know exactly what the horizontal asymptote is. And this takes us a little bit of time, a little bit of thinking about it. But let's do the first couple by hand. If we were in class, we would take a lot more time doing this by hand, just so we understand what's going on behind the scenes before we used a calculator. But in these notes, in these videos, I try to go as fast as possible. So if I plug in 1, let's find the function value when x is 1. So it'd be 3 times 1 squared minus 2 over 1 squared plus 4 times 1 plus 1. And that would give us 1 over 6. All right. Not a lot to take away there, but let's try to plug in 10. Now, if I plug in 10, I would do 3 times 10 squared. Now, 10 squared is 100. 100 times 3 would be 300 minus 2 over 10 squared, which is 100, plus 10 times 4, which is 40, plus 1. So this would give me 298 over 141. So the whole point of doing this is to see a pattern. What are these y values approaching? I've only done 2 of them. This one was 1/6. This one was, I don't know, basically 300 over 150. What number do you think is going to be approaching? Let's plug in 100. So if I do 3 times 100 squared, 100 squared is 10,000, minus 2 over 100 squared, which is 10,000, plus 400, plus 1. So as I plug in huge numbers or bigger numbers for x, subtracting 2 and adding 1 doesn't have much effect on the actual value of the top or the bottom, right? It's pretty not impactful. And the next not impactful part was that 400. So if I was to add this up, what would I even get? 30,000 minus 2 over 10,401. So this would be about, I did this earlier in my calculator, 2.8841. What number do you think it's approaching? Now we said subtracting 2 doesn't matter as much, adding 1 doesn't matter as much as I'm plugging in huge numbers. As I'm plugging in huger and huger numbers, really the square part is the important part. Multiplying by 4 and then adding it won't have as much effect. And I'm going to go and fill in the rest of these quickly. It starts to level off, right? Y'all notice? And so what would you think the limit is, or what are these values approaching as I plug in huge and huge numbers? And the answer is going to be 3. And you might think, or might notice, that is the quotient of those leading coefficients, that 3 over 1. So all we're really going to look at is the biggest degree. That's what's most important. And if it's the same degree on top and bottom, we look at those coefficients. And you might remember that Bobo, Botan, and then we called it Coco. You might have called it something else. But that is coming to effect here. All right, so if I can look at this one, I could plug in numbers and I could think about this and I can make a table. I can use my calculator and just really like spend a lot of time on it. But if I'm looking at the limit as x is approaching infinity, I'm plugging in huge x's. As I plug in huge x's, adding 7 won't change the overall number that much. Multiplying it by 5 won't change the number as much. So what I'm going to look at are the biggest degrees, or the greatest magnitude, which we'll talk about in a second. And then I look at the coefficients. So this one would be 3 over 2. Because I plug in huge numbers, squaring it changes it. That's kind of the most effect. And then multiplying the top by 3, multiplying the bottom by 2, you always have that ratio of 3 over 2. And here's a little hint. It says, when working with limits as x approaches infinity, don't sweat the small stuff. Don't look at like the little degrees. Don't look at the little magnitudes. Look at the biggest. Let's do a couple more examples. So find the following limits if possible. So limit as x approaches infinity. Don't care about the little stuff. There's the biggest is the squareds on top and bottom. So the degrees are the same. So I'm going to say it's 1 over 5. The next one, I think, okay, the smallest magnitude might be 3x. But there's another one, and I'll be multiplying that together, right? I can multiply this all together. I could do FOIL, box method, all that stuff. But all that I really care about is the biggest degree, or the biggest term, would be negative 6x squared plus minus more stuff, right? Over 3x squared minus small stuff. So this, I would look at the biggest degrees, and that'd be negative 6 over 3, which is negative 2. That would be the limit. All right, C is slightly different, something new we haven't talked about. But still the limit as x goes to infinity. If I look at the biggest degrees on top and bottom, I could say this is equal to the limit of 4x squared over x cubed. Now I kind of just, those limits are going to be the same because I'm looking at the biggest magnitudes. But this time the bigger magnitude is on the bottom, right? So the bottom is growing huge, huge, huge compared to the top at bigger numbers, right? So I would just be getting some number over a number that's blowing up. So I have like a number over infinity. So this limit's going to be 0. The bottom is getting infinitely huger than the bottom as I plug in huge, 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 huge numbers. So add infinity. So the bottom is a lot bigger than the top, and we said that was Bobo, bigger on bottom, so it's going to be 0. So the bigger degree is on top, there's going to be no horizontal asymptote. If the biggest degree is on the bottom, it's going to be, the vertical asymptote is going to be 0. And then if the degrees of the biggest exponent, they're the same on top and bottom, you divide the coefficients. All right, so maybe you want to pause this, do these 3, see what you get, and then watch whenever you're done. So this one, I'm going to look at, well, limit as x approaches infinity. The biggest degree is on top. If the biggest degree is on top, then the horizontal asymptote, you could say is like infinity. But that's not going to be a thing, so we're just going to say there is no horizontal asymptote. All right, the next one, if I was to multiply this all out, 3x minus 7 times 3x minus 7. All I really care about is that the biggest degree, the biggest magnitude would be 9x squared plus blah, 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 blah. Who cares? And the smallest, even though it's out of order, is going to be the negative 5x squared. So this limit, since it's the same degree on top and bottom, I divide the coefficients to get negative 9 over 5. All right, last one, part C. It's a little different. We don't know, what is the magnitude of sine? Well, I'm trying to figure out, sine just cycles through, right? The highest it gets is to 1, the lowest it gets is to negative 1, over x, which is growing without bound, right? So at infinity, the denominator is getting bigger and bigger and bigger and bigger and bigger. The top is oscillating between 1 and negative 1. I guess I shouldn't say the word oscillating, but it's just kind of fixed, right? So this one, the bottom is growing huge, so this limit would be 0. All right, that's it for this part of the video. I'll make more videos for the other part.